OCR paper I started the other day. This is question 3. The function f is defined by x minus 3 squared minus 17, where x is greater than k and k is a constant. Given that f to the minus 1 x exists, state the least possible value of k. So this means that this could end up being a square root. And if that's a square root, then k has to be 3 or greater, or 3 or more. Evaluate f of 5. So let's put 5 in. So we get 5 minus 3 squared minus 17. So that's 2 squared, which is 4, minus 17 equals 30, minus 13. Now we should put minus 13 back in again, but we're not really allowed to because we know that k has to be greater than 3, greater than or equal to 3. So this is where it's maxing out or minimizing out, I suppose, at minus 13. Solve the equation f of x equals x. So if we did, let's do it down here, x minus 3 squared minus 17 equals x, then we'll expand the brackets and we get x squared minus 6x plus 9 minus 17 equals x, and that gives us x squared minus 6x plus, no, that's going to be minus 8 equals x. Now we'll take x off both sides, so we get x squared minus 7x minus 8 equals 0. And in this case, x squared minus 7, so this is going to just be, let's just have a little look at what we get. So we get x, and I think it's going to be x minus 8 and x plus 1. So that means that x equals 8 or negative 1, and in this case we're just allowed to make it 8 because we're still working in the same confines, so x equals 8. Right, explain why your solution to part C is also the solution to fx equals f to the minus 1 of x. So these two things meet. So they meet, or at least they are reflected through y equals x. So when so if we just make this equal to x, that means we're also going to the point where f to the minus 1x would meet. So it means it's the answer for both. Because they reflect through y equals x. So that one does that, say, and if that one does this, then this one does that. So they meet at the same point. Right, Sam starts a job with an annual salary of 16,000, and it is promised that the salary will go up by the same amount every year. In the second year, Sam is paid 17,200. Finds Sam's salary in the 10th year. So the way to do this is, in year 1, you just have A, which is 16,000. In year 2, you have A plus D, which is 16,000 plus 1,200. And then, so that means in the 10th year, you would have A plus 9D, which would be 16,000 plus 9 times 1,200. Which equals 16,000 plus 9 times 1,200 equals, let's just try that again, 16,000 even plus 9 times 1,200 equals 26,800. Now, find the number of complete years needed for Sam's salary to Sam's total salary to exceed 500,000. So we're going to have to use the arithmetic sequence. So the sum has got to be 500,000. And n we don't know, so that's n over 2. And then 2a is 2 times 16,000 even, I've got to stop doing that, plus n minus 1 times d. Hang on, it's got to exceed this, so it's got to be that way around. D is 1,200. And then we just solve that, which will involve, so 500,000. So in the middle you've got, so that's n over 2, and that is 32,000 plus 1,200n minus 1,200. And that goes to, let's times that out by, so 1 million. It's less than n. So let's do 32,000 n. Plus, oh no, yeah, okay, plus 1,200 n squared minus 1,200 n. So that means we have on this side, so 1 million, and then that would be, it's less than 1,200 n squared, and that's 32,000 minus 1,200 equals 30,800 n. Okay, now we can divide this through by at least 100. So we get 1, 2, 3, 1. Sorry, that's 10,000. It's less than 12n squared minus 308n. I don't know what the 308 divided by 12 works. Nope. So 308 divided by 2. So we can divide both sides by, oh, actually we are. So divide that through, was 5,000. 6n squared minus 154n. So let's now just go 154n minus, or rather 6n squared minus 5,000. So that would be, let's just have a little look. So 6,154 minus 5,000. So that's 18 or 19. So it would be at 19 years, so 18.75. Therefore, 19 years. Okay, it's a very slow process. Comment on how realistic the model may be in the long term. While he might not stay in the same job for 19 years, not everyone stays. Also, they might max out the salary they're willing to pay. Right, there we go.